Hello, this is Mrs. Taylor, and I wanted to review with you how to graph linear equations. There are two ways that you can approach this. Either you can find the intercepts, or you can change your equation to slope-intercept form and use the slope and the intercept. So I'll show you both ways. The first one, using the intercepts, you have to remember that the x-intercept is where y is 0 and the y-intercept is where x is 0. So if I use that, I can start first by replacing my y with 0 and then solving for x to get my x-intercept. So 3x plus 0 is 3x, and then 3x equals 2. I would finish by dividing both sides by 3, and I would get x equals 2/3. And then if I repeated that process to find the y-intercept, I would substitute 0 in for x. And then 3 times 0 would be 0, and 0 plus y is just y, and so y would equal 2, and that tells me the y-intercept is 2. Now, for this particular problem, I may not choose to go that route because x-intercept is 2/3. I'd have to estimate where that is on the x-axis, and that wouldn't be very precise. So I'm also going to show you how to get this in slope-intercept form. Slope-intercept form is where y equals mx plus b, or y is by itself. So in order to get this equation in slope-intercept form, I need to isolate the y. It's 3x plus y equals 2. If I undo adding this positive 3x to the y, I can move the 3x to the other side of the equal sign. So I would do that by subtracting 3x from both sides. So I'd subtract 3x here, and I'd subtract 3x here. And once I do that, 3x minus 3x, that cancels. 2 minus 3x, well, those aren't like terms. So I would just have to leave them separate as 2 minus 3x. Now I have an equation in slope-intercept form. It's not exactly slope-intercept. Technically, it should be y equals mx plus b. And so if I wrote it in that way, all I would need to do is switch the negative 3x and the positive 2 so that the x term is first. And that's truly slope-intercept form. But the reason why that's so helpful is the b value, the constant, is my intercept. Which intercept? It is the y-intercept. So that means that on my graph, I would have a point at 2 on the y-axis. And then my slope is negative 3. And that tells me that from this y-intercept, I would use the slope of negative 3 to find my next point. Well, what we've learned in class is if I have a number that is not a fraction, I can turn it into a fraction by putting 1 underneath it. The reason you want to do that with slope is it's your rise over your run. And so if negative 3 is on top, that means I go down 3. That's your rise, negative 3. And then if 1's on the bottom, it's a positive, so that means I move to the right 1. And I can repeat that process again to get another point. So from that point, I would go down 3 over 1. And then I would just connect those points to get my full graph of the line. Well, that doesn't help because that's a white line. So let's try blue. So that would be the graph of my line. Or my equation, 3x plus y equals 2. Now, number 8, I can approach the exact same way. I can choose to do the intercepts, or I can solve for y. So I'll show you both. If I chose to use the intercepts, first I'm going to find the x-intercept by substituting 0 in for y. Negative 2 times 0 is 0, and x plus 0 is just x, so my x-intercept is 6. To find my y-intercept, I substitute 0 in for x. It would look like this. And then this would be 0 minus 2y, which is just negative 2y. And then I'd finish by dividing both sides by negative 2. So y would equal negative 3. Now this is an example of where the intercepts can be an easier route, because x equals 6, y equals negative 3. Those are coordinates that I can find without estimating on the graph. However, this graph doesn't have 6. Again, I would have to estimate that it's about here on the x-axis. The y-intercept is negative 3, and then I could just connect those two points together, and that would give me the graph. Now, if I chose instead to do slope-intercept form, get y by itself, I'm going to retype it down here so I have more room. The first thing I would do to isolate the y is I would need to move this x term. It's a positive x, so I would add x to both sides. Oh, excuse me, it's a positive x, so I would subtract x from both sides. And the x's on the left side, x minus x, that's 0. And so you'd be left with the negative 2y on the left side. 6 minus x, those are not like terms, so I just write it out. So I'd have negative 2y equals 6 minus x. I still have a negative 2 in front of my y. And so I need to think, okay, well, what operation is that? Negative 2y means negative 2 times y. And to undo that, to isolate my y, I would do the opposite, which is to divide. And if I divide the left side, I have to divide the right side. So I divide both sides by negative 2. The negative 2's here. Negative 2 divided by negative 2 would be 1. And 1 times y is just y. So that leaves you with y on the left side. And then on the right side, I have to remember that if I divide, I have to divide each term by the number I'm dividing by. So 6 divided by negative 2 is negative 3. Now negative x divided by negative 2, there's a lot of things going on here. First of all, I have a negative divided by a negative. And when we learn integers, we learn negative divided by negative makes positive. And then I have to remember that in front of this x, because there's no number, there's an invisible 1. So really this is 1 divided by 2. Well, that's a decimal. So I'm going to leave it as a fraction, because fractions are preferable. So that would be 1 over 2, and then x. So I'd have my 1 over 2 as my coefficient. And again, if I wanted to rewrite it in precise slope-intercept form, I could. I can move the 1/2 x to the front, and I would have y equals 1/2 x minus 3. Either way, I can look at this and know my y-intercept is negative 3. I already have that plotted. And then from that point, I would use the rise over the run. They're both positive, so I would go up 1 and to the right 2. So from this point, I would go up 1 and to the right 2. Up 1 and to the right 2. And if you look, it follows that line I had already graphed using my intercepts. So that's the way you would graph a linear equation if they gave you a form that wasn't already slope-intercept form. You may have to find slope-intercept form, or you can just use the intercepts. It's your choice.